Hello YouTube, welcome to part 2 of this grass shader series. I'm here in the final completed project, and in today's episode we are going to be rendering the actual planes that the grass texture is drawn on top of. So if you can see here, it's just basically a plane and there's just thousands of planes here. They're all rotated in random directions, and we've just slapped a texture on top of that. So we're going to be actually rendering that plane. So if we go back to where we left off last time, it's this rather uninspiring plane right here, and we're going to take every vertex on this plane and extrude it to create a bunch of new planes basically. So the idea of how this is going to work is, if we go back to the code where we left off, you can see that we are getting an input, which is an input of triangles. So if we go into the input of basically what the input of triangles is given our base mesh here, which is our plane. We are given a random triangle within this plane here, and this triangle has 3 vertices, so we're given all 3 of these vertices, and this is this varyings input here. Remember, varyings is our struct that defines all the information about this vertex. So what we do is, once we have these 3 vertices, we basically get the average position, and let's say it's that dot here, and from that average position we go towards the right a little bit and we place a vertex there. We go towards the left a little bit, place a vertex there. We go up and then to the right and place a vertex here, up and to the left and place a vertex here. Now we have these 4 vertices. We can create our 2 triangles that generate our plane, and using this we can, once we have created the triangles, we can assign UV coordinates. Okay, we can assign our UV coordinates here, so it'd be something like 1 0, it would be 0 1 1 1, and that would be our UV coordinates that we assign. And once we have created the plane, we just slap a texture on it, and since the UV coordinates are set up correctly, the texture will correctly fit on this plane. So that's all we're going to do in this episode. We're just going to create the plane, and also we are going to rotate the plane randomly, so we get a bunch of random rotations. Quick reminder, if we have a plane, what goes up is the normal vector. So this is your normal vector here, and what goes across the plane is the tangent vector, and then what is at right angles to both of these, or the cross product of the normal and tangent, is the bitangent vector, and this is your tangent space. Now usually it would be important to know that, but since in the last episode what we did is we got the position object space, normal object space, and tangent object space, and we just converted it to world space. We did that here using URP's helper functions. So now that everything is in world space, we just have to add a bunch of stuff and everything will work out. Hopefully, we'll find out. Okay, so the first thing we need to do is get that average position of the 3 vertices, which is the middle of the triangle that we've been given. So very simple. I just create a float called base pos, and let's say input 0 dot position ws and fog factor, and WS stands for world space, by the way, and we can say XYZ. So basically what we're doing is we're going up here and we have this position world space. Remember, XYZ is the position and W is the fog factor. It's the amount that the fog affects this current vertex, because fog in Unity is calculated in vertex space. By per vertex, sorry. Yeah, so we have this, and we're just getting the XYZ because that's what the position is. Now we can add this 3 times, 1 2, and we divide by 3, and you have your average position. Now we need to create 4 vertices, so let's do this in the most hacky way possible. So let's say varyings O is equal to input 0, and since we're setting it equal to input 0, all these values have been assigned already, so we don't have to reassign them basically. Okay, now we need to say float 3 new world space O, it's too long. Let's just say O pos is equal to base pos minus O tangent world space. Remember, O already has tangent world space. Base pos is the middle position, so by our calculations wrong paint, by the way. We are starting in the base pause, and then we're going to the left along the plane. So this is the vertex on the left, and then we need to assign its screen space. So if you remember, what gets drawn on the screen is actually defined by this screen space position right here. So because the fragment shader uses that to determine where on the screen it is. So that is what we need to assign to tell the GPU basically where this vertex is. So it's very simple. We just need to say o.position cs is equal to transform world to h clip opos. Now transform world to h clip converts the world space to the clip space or the screen space. So once that's done, that's basically it for our first vertex. Now we need to do this 3 more times. Let's just copy it, and let's just change the names. Make sure you change the names correctly or we're gonna have trouble. So this will be 0, 2, 3, and 4. Make sure you need to change the names in everything. So let's change this to O2 pause, O2 tangent world space, O2 pause, O2, O3, 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 O4, 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 and O4. And once that's done, we actually need to change where it gets rendered. So the second one, we're just going to make the right. So we're adding the tangent world space. So if this is the base position here, we're going to the right. So yeah, this is the right one. And then now we need to create the top right. Top right would just be adding tangent, and we're also going to add the normal. So we're going up and then we're going to the right is basically what this is. And now the base position would be the opposite. We're going to add the normal, but we're going to subtract the tangent. So we'll go up and then to the left. Now we have our 4 vertices. Now we need to combine them in a way that creates 2 triangles so we can have our plane. So the way we can do this, we can say outstream dot append 04, and we can just copy this, and we need to append 04, then 03, then O. So that will go from your top left to your top right, and then to your base here. So it will create a triangle like this. And then we need to ensure that we say outstream.restart strip, telling our triangle stream here, okay, this is one triangle, and we're going to create another triangle. Let's copy restart strip, and now we need to change the order. So this would be 03, 02, O, and if you draw this out, it should create a plane. So now if we head back over, we should see a bunch of squares. Very just not helpful if you ask me. So the best thing we can do right now to visualize this better is we can give some control over the height and base. Now if we go back over here, remember that we added a height and base float here, and we also brought it in right here. So we're going to take this, so we're going to say height, and we're going to multiply the height by the normal. Okay, so that would make the most sense. We're going to multiply the height by normal. So let's copy this and make sure you put this everywhere normal appears, which is only 2 places. And then we need to multiply the base by the tangent world space. It would affect how much it goes right. So that's the 3 places here. If we go back here, we can go into the material settings and we can play with the base and the height. Okay, it's still not that great. So why does it look this horrible? Well, it's because firstly, there's no lighting, and secondly, there's no randomized rotation. So rotation is very interesting. The way we achieve rotation with these planes, because they don't exist, you can't select them and hit rotate. The way you achieve them is through rotation matrices. So if you go into Wikipedia for rotation matrices, I just pulled these 3. These 3 are very useful rotation matrices. You just pass in theta, and then it will give you back a matrix which you can multiply to a vector, and it will rotate that vector. So the what we'll do is the only vector that we need to rotate is our tangent vector. So remember, our tangent vector would be useful if there was like an arrow thing. I don't know. Here we go. let's use this. Our tangent vector is pointing in this direction right now, basically, and because of that, our points are being drawn like this. So there's a point here, and then the point here, point here, point here. Now what our goal is going to be is to rotate this tangent vector by multiplying it by ry, because an r rotation y matrix, because if you look back at Unity, when you want to rotate in this direction, right, we want to rotate it flat, but in a circular motion, while without like elevating it. It's this y1 right here, so we want to multiply by the y rotation matrix, and if we do that, it will soon rotate, say, the tangent vector to face this way. So now our vertices will be placed here, 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 and here, and therefore we have successfully rotated our plane. So that's the idea that goes into this, basically. So yeah, let's do that. But before we do that, we actually need to create the rotation matrix like generator. So let's go ahead and do that. Let's say float 3x3, because it's a 3x3 matrix as shown here, and let's call this rot y, and let's give it a parameter of an angle, and I think this is in radians. This might be in radians. I'm not sure. Let's figure it out, but radians or not, I'm not sure. But we'll return float 3x3, and this is not like this, it's with parentheses, and we are going to return basically whatever it says here, which will be cos angle 0, sine angle, and we're going to 0, 1, 0, and negative sine angle 0, cos angle, and that will rotate when we multiply this matrix to the vector. It will rotate it by the angle, hopefully. So now once we have that, we can just create the rotated tangent. So let's go here and say float 3 rotated tangent. We can say we need to normalize it because we're multiplying by a matrix. We don't know how it's gonna extend that. So it's multiply. That's the multiply function to multiply a matrix and a vector. So we're going to multiply the O dot tangent world space, okay, by the rot y and by an angle that we need to provide it with. Okay, now the angle that we're going to provide it with, I want to provide it with a randomized angle. Okay, so in order to do that, we will have to create a randomized function. Now I just pulled this off the some forum. I honestly don't know how this works. I'm gonna paste it in, and you guys can copy this down. But you pass in a float 3. I think it acts as a seed, and when you pass in a float 3, it produces a random number. I'm pretty sure all it does is put it into some type of, like, get out some type of sine texture wave, I don't know, but it turns a float 3 into a random float. If you know exactly what this is doing, please let me know down in the comments. Would be much appreciated. But yeah, we have this rand function here, and we can pass that into this angle. So now we have a random angle, so we can say rand, we can pass in the coordinates of the grass vertex, so we can say position, world space, and fog factor, and we can xyz, of course, and then we can multiply this by 90 to give it some scale, and now we have our rotated tangent. Okay, now all we need to do now is remove O.tangent.world space and replace it with a rotated tangent. So let's just do that everywhere. And if we go back in, we have an error. Yay! Let's see what am I doing wrong. What identifier doesn't it like? O. It doesn't like O. Oh, we're just doing this up before we declare O. Okay, so hopefully that should clear everything up. No, there's another one. Normalize. Doesn't like normalize? Or I'm just missing a bunch of brackets. There we go. Parentheses. And there we go. We have a bunch of randomly distributed planes, and while you might not be able to see it without lighting, here we go, we can decrease the base. I think 0.5 should give us squares. And yeah, we have randomly distributed planes here, and they're quite messed up, but with a transparent texture this will look so much better. But yeah, you can see that the planes are being created in the right order, and they look like they should work, which most usually means they should work. But yeah, that's creating this. Now guys, I was going to create the wind movement in this episode, but I think it would be best for me to write the lighting and the texturing of this before we actually get into the wind movement, because that seems like a feature that should be added later. So one thing that I'm going to append to this before we finish off is actually finishing the like setting up the UVs for this these vertices. So that should be quite simple, honestly. It should be easy. So let's create this. So let's set the O4 UV to equal to transform text. So first we need to pass in what mapping it is. So O4, right? O4, we look at, hold on, it would be best if I show you this. We have our plane here, and this is O4 right here, because we're going to the left and then up, and we have O3 over here, and then we have O1 or O here, and we have O2 here. So the way we're going to set up the UVs is make O4 equal to 0, 1. I think this is different to what I said before, but it's 1 since it's at the top, and then this would be 1, 1, and this would be 0, 0, and this would be 0, no, 1, 0. Okay, so once we set this up, we need to use this method and constrain it, or not say that this is for the base map, and I'm pretty sure it does some calculations behind the scenes that makes this correct. Okay, so let's just correctly map all of these. We can just copy this in, and we need to change the value. So O2 would be 1, 0, and O would just be 0 and 0. So that's our UV setup, and we need to set one more thing up. It's our normals. Actually, is it? Yeah, we need to set up our normals, because note that our normals right now, since we got our vertices from a plane like this, right? These are some random vertices in the plane. The normals were going up, but one important thing to note is we have planes sitting on this plane, right? So the normals now actually have to come out, if you think about it, because this normal does not equal this normal. So lighting will be all messed up if we do not switch the direction of this normal. So how do we switch this? Well, all we have to do really is we need to rotate the tangent. We need to well, if we have our tangent, right? So let's say we are given this plane, right? We are given this plane. Right now we have our tangent going across here. Okay, all we need to do to get this is to rotate our current tangent by 90 degrees, and then boom, we have our normal. So this seems like a pretty innovative solution for this. So all we need to do is rotate our tangent. I bet there's a better way, but it seems like it works for now, so let's just keep it. So let's say our new normal is equal to the multiplication of our current rotated tangent. It's not just our tangent, it's our rotated tangent. And we're going to use our function that we wrote before, rot y, because we're still just rotating across the y-axis, and we're going to rotate it by 90 degrees. And I figured out that it was radians, I believe. So we're going to divide it by pi divided by 2, and we actually need to define pi, or no, actually I think it comes inbuilt. Yeah, but pi divided by 2 is our new normal, so our normal should be facing outwards now. So remember, all we're doing is wherever it is, I don't know where I put it, but we are rotating our tangent which goes across our plane, because remember we are putting vertices across our tangent like this. Now we're just rotating the tangent to face outwards. It doesn't matter which direction it is, but it will still be a normal. So that's all we need. Now we need to set the normal. So let's get O dot normal world space is equal to new normal, and we need to repeat this for the 4. And now we have our normal set up, our UV set up, our position set up, and that should be enough to lead us on to the next episode nicely. It really shouldn't make a difference here unless we have an error, which of course we do. Incorrect number of arguments. Okay. Oh, this is just float 2, my bad. Not float, there we go. And we should be okay, there we go. It's still the same result because the normals don't actually have any effect right now. We need to implement the lighting to see their effect, which is all done on the fragment shader, which is on the next episode. Remember, the full code is in the GitHub repository that I linked down below, so you can go check that out at any time. So you don't need to wait for the next episode, but I hope you'll tune in next time. I hope you guys had some fun, and I'll see you next time.